deflection WAEC 2011 on galvanometer. It says an ammeter with a full scale deflection of 10 milliamps has an internal resistance of 0.5 ohms. Calculate the resistance of the shunt required to adapt it to read up to 3 amps. Okay, so basically here we are converting the galvanometer to an ammeter. So I could just write the formula. We write out our parameter. Our parameter here says an ammeter with a full scale deflection current. So that means our galvanometer current equals to what? 10 milliamps, which in standard unit means what? 10 times 10 raised power minus 3 amps. So the next parameter here has an internal resistance of 0.5 ohms. That's small r. Resistance of the galvanometer is 0.5 ohms. Then calculate the resistance of the shunt required to adapt it to read up to 3 amps. So ammeter reading, which is I, that's the range, the value, the range of value, or should I say the value of current we want it to read up to. The highest value of current we want it to read up to is 3 amps, or you say ammeter reading 3 amps. So we have to find what? Calculate the resistance, that's the shunt. That means the resistance connected in parallel to the galvanometer. So what is the value of such resistor that we're going to connect in parallel for our ammeter to be able to read up to 3 amps? So I could just write out the formula here that R will be equals to what? Galvanometer current times its internal resistance divided by the ammeter reading minus the galvanometer current. This is the formula, and we already described how we get to this formula in one of our videos on how to convert a galvanometer to ammeter. You can check it up. So let's substitute. This will be equals to our I subscript G is 10 times 10 raised power minus 3 times R. Our R is 0.5. 0.5 is 1 over 2. Okay, divided by our I is 3 minus I subscript G, which is 0.5, or still a half. Sorry, our I subscript G, that is a mistake there. Our I subscript G is 10 milliamps. That's 10 times 10 raised power minus 3. So if you keep doing this, these 2 here will cancel this 10 here 5 times. So you have 5 times 10 raised power minus 3 divided by 3 minus, here what you have here is 10 divided by 1000. 10 raised power minus 3, 10 times 10 raised power minus 3 is the same as 10 divided by 1000. So which is 1 divided by 100. So this will be equals to 5 times 10 raised power minus 3 divided by 3 minus 1 over 10, 1 over 100 is equivalent to 0.01. So 3 minus 0.01. So 3 minus that, this is 5 times 10 raised power minus 3 divided by 2.9 3 minus that will give you 2.99. And then if you do 5 divided by 2.99, so if you do 5 divided by 2.99, you will have okay, let me write it down here. You have 1.6722 dot dot dot. Then remember, we still have times 10 raised power of what? Minus 3. Remember, on this numerator. So this divided by 1000 or times 10 raised power minus 3 will give you 0. Give you 0 point. How many? Okay, will give you 0.001672, which is approximately 0.00167 ohms. Or you can choose to leave it in standard form, which is what? 1.67 times 10 raised to the power of what? Minus 3 ohms. So the value of our shunt resistor equals to 1.67 times 10 raised to the power minus 3, or you say 0.00167 ohms. Thank you.